Okay, so this is the Algebra 1, Section 1.4 Distributive Property. Well, here's the key notes, and this distributive property is very important to grasp for future lessons because it will be handy dealing with variables, because that's pretty much where math is going, is more and more variables, which I know is a pain, but that's just the way it is. These examples I show are just numbers, so they don't really do good justice. I'll try to find an example of how this works with variables. I may just throw one in there so you can see what that point is. But the general form is, for any numbers a, b, and c, a times b plus c equals ab plus ac. If you notice, the a went to both terms and is still attached to them, so I multiply those numbers together. Also, that works for if it's a times b minus c, so that's a times b, that equals a times b minus ac. Here's the number of examples I mentioned earlier. This is going to be 3 times 2, that's right there, 3 times 5, which is there. And I'm going to show you that they equal the same thing, because 2 plus 5 is 7, so 3 times 7 is 21. 3 times 2 is 6, 3 times 5 is 15, that gets us 21 as well. Again, I know for numbers you're probably thinking, why would I do that? Well, and I'm saying this, if you understand with numbers, the idea is, the hope is, that when you just add letters, it's the same process. Nothing changes in terms of the process. Okay, what the answer looks like changes, but the process doesn't. Here's another example. It's 4 times 9 minus 7. So 4 times 9, there. 4 times 7, there. Minus stays there, okay, like the plus. This stays plus, this stays a minus, all right? So we get 9 minus 7, 2. 4 times 2 is 8. Then we get 4 times 9 is 36. 4 times 7 is 28. Subtract them, we get 8, okay? I'm going to do some examples with some variables to see the difference. The other two notes worth having are these things called like terms. We'll make it very simple. Like terms are terms that have the same variable with the same power. That's basically it. So I have an example. 2x squared plus 4x squared minus x. These, let me get that right, this pencil right here. These are like terms. Sorry if you can't read it, but those are like terms. You see, they have x squared, right? X to the power of 2, both of them. So those are like terms. This minus x is not a like term, all right? Because see, it's just x to either 1 power or there's no powers there. So those are not like terms. What you can do with like terms is you combine them. And mostly we will try to get things to its simplest form. Its simplest form includes, if I add these two together, that'd be 6x squared, because I just add the 2 and 4. Okay, I don't add the x squareds together and get like x to the 4th. That's a no-no. We just add the 2 and 4, that gets us 6x squared minus x. See, the x is still by itself. That's simplest form. What we added, this 2 and this 4, we call those coefficients. Okay, so we add the coefficients together. That's basically all we're doing when we have like terms. We add coefficients together. How I phrase it is coefficients are mostly the numbers in front or attached to our variables. That's, I think, the easiest way to understand it. And here's an example. I have a 4ab. A, b are variables. The 4 is the coefficient because it's the number in front of it. Now, I used the word attached earlier. This is x squared divided by 3. See how the 3 is not in front of the x squared? But I know I can write as a fraction as 1/3 because see, it's being divided by 3. So it's being attached somehow. Mostly your coefficients will be either multiplied or dividing the variable. They'll be either multiplying the variable or dividing it. You'll never get a coefficient that says 2 plus x, because then the coefficient of that x is just 1. For example, this coefficient is a 1. I know it's not there, but if you saw it, remember from the properties of real numbers, 1 times anything is just that thing. So there's your notes. If you need to write them down, pause it real quick once I move out of the way of the camera, and we'll come back and do some examples. Okay, so let's do some examples from 1.4. So, first one is number 2, and the instructions in the book that I'm using says, use the distributive property to rewrite each expression, then evaluate. So we want to use the property. So basically, what they're looking for is to rewrite this as, I'm going to go down, so it's going to be 14 times 50 plus 1. I know, it seems counterintuitive, but the idea is to get practice of using the distributive property. So now we just go 14 times 50, which is 700, I believe. Plus 14, because 14 times 1, because it goes each term, that equals 714. Again, the process of this, I know you could just probably go 14 times 51, but that's not the point. The point is to get used to using the distributive property, all right? So we're going to do the same thing here, all right? And this one's actually pretty useful. This becomes 6 plus 1/9 times 9. All right, so now we go 6 times 9, which is going to be 36. Not 36, my bad. 6 times 9. Even I'm bad at math sometimes. 54, that's better. Plus 1/9 times 9. Now, from 1.3, we learned that every multiple has an identity. So the idea is, imagine this is being divided by 1. In this case, 9 times 1 is 9. 9 times 1 is, or 1 times 9 is 9. 9 times 1 is 9. So 9 over 9 is just 1. So this equals 1, which equals 55. Fractions and stuff like this, it might be easier to separate them out like that. Okay? So the distributive property is nice to make fractions easy. Now, I mentioned that I was going to do something with a variable. Those 2 and 3 are pretty just, you may just be able to plug those in the calculator and go. Variables is where our game is going. So we're going to have 2 times 4. So it's going to be plus 2 times t. All right. Now, 2 times 4 is 8. So that's going to be 8. 2 times t, that's not like a number like 8. It's a number with a variable. That's just going to be 2t. Boom. That's all you do right there. Okay, so let's do the same thing. Notice how the 5's on the outside of it instead of in front? It doesn't matter. It does the same process. So 5 times y minus 9 times 5. You notice I wrote them differently too? In the grand scheme of things, it doesn't really matter. It's the same idea. So this becomes 5y minus 9 times 5, 45. Circle our answers. That way you know they're done. There we go. Okay. Like I said, the variable part is where you're going. So this is actually very important for you guys to understand as students. The next part is 7 and 8. It's saying simplify each expression. That is, if not possible, write simplified. So when we say simplify, it means combine like terms. Okay, that's what I talked about with the notes. This one, if we look at it, it says 3x to the cubed plus 5y cubed plus 14. Remember when I said like terms, they have to have the same variable with the same power. But look, there's no other terms with x cubed. There's no other terms with y cubed, and the 14 is by itself. So by virtue of there being no like variables to begin with, and those variables aren't on the same power, we're going to say this one's already simplified. If I can spell simplified, that'd be helpful, but it's probably whatever. Okay, so number 8, we need distribute. So we have 2 ways we can do it. And since we want to use the distribute property, because that's the name of the section, let's go ahead and distribute. So we get 10 times 5. So we get this. We get 10, since it's on this side, I'm going to 5m I get that. 5m times 10 plus 2m times 10. So we need to multiply the 5m times 10. Multiply the 5 and the 10. The m is a variable. It's just kind of, it goes with it. So 5 times 10 is going to be 15. Okay, we need to do the same thing with 2m times 10. Again, the m just goes along for a ride. We get that. Those are like terms now. Remember, they both have m in common, and they're both to the same power. So add that together and get 70m. Okay. And there you go. That's the distributive property in a nutshell. Of course, it does get complicated as more you go, but in terms of the process never changes. 4 and 5, I think, are the big ones you want to make sure you pay attention to and make sure you know how to do. Okay. In terms of other problems from the examples, if you go, it takes stuff from making simple words. So if you look at 1.2 examples and you're related, you'll be just fine in terms of that. So that's the distributive property. Hope that helps.